Welcome back to another episode of Greenprints. I'm Catherine.
And I'm David. In this episode, we are going to be looking at new builds. So, not just maintaining older homes, but actually building sustainable and long lasting elements into brand new homes.
That's right. I had the pleasure of sitting down with Tom Cumming of Severn Woods, a Toronto based builder and renovator with over 2 decades of experience. And Tom has a deep understanding of what makes a house not just beautiful, but also comfortable and forward thinking.
Yeah, the whole issue of sustainability. I mean, homeowners aren't really going into a new build thinking sustainability or longevity, things like that. They just want to make sure that their house isn't drafty, they don't have a damp basement, all those basic things. But in order to do that, of course, the house has to be built, properly.
Yeah. Yeah. He did mention that, a lot of his clients are trying to just eliminate dank basements. They want more light, higher ceilings, a lot of things that you don't find in a lot of downtown homes, which is where he did specify a lot of his clients come from, downtown Toronto, and those old Victorian homes that we spoke about
Hmm.
in our last episode. And he essentially said that by eliminating drafts, stabilizing indoor temperatures, and improving air quality, these are all kinds of building practices that he focuses on. And then to that further extent, looks to improve energy efficiency and durability of the home.
Yeah, so I'm really looking forward to hearing, what he has to say about those topics. It's certainly of major interest to us here in this podcast, to Catherine and I. Like as we said, a lot of the homeowners aren't really thinking about those things. You're thinking about the aesthetics, you're thinking about, maybe the quality, but not necessarily those details that do make a home last, for a long time.
Yeah, he touched on the emotional and the practical side of demolishing a home.
Hmm.
But especially in these older neighborhoods, there isn't room to adapt all these great features
Hmm.
that one wants in a home. And that's where kind of a new home is kind of required.
Right. Yeah. I mean, demolition, one could say, well, you are sending more, material to a
Mhm.
landfill. You are, basically the embodied carbon in building that original home,
Kind of going to
kind of goes to
waste.
waste, right?
Mhm.
But really, as you say, there's not much you can do with an older home, and in fact, sometimes the square footage is an
Yeah.
issue, and especially a lot of the urban locations, they want to get more of a more square
Density.
footage, yeah, more
Yeah.
density on the same footprint that the city bylaws and the property will allow.
Okay, so let's start the conversation maybe with where Tom and his company would fit. So, in the scenario where a homeowner comes to him first looking for a new custom home, him or really any builder, right? So, the hope is that they're going to a builder with a certain laundry list of things in mind.
Hmm.
Where Tom comes in is he introduces them to a designer and architect,
Hmm.
and he said he has a handful of architects that have sustainable practices.
Hmm.
And then on his side, he has a whole list of suggestions when it comes to build practice and also build materials.
So in that case, the builder and the architect are working hand in
They're
hand.
working hand in hand. And then this is where he tries to educate the homeowner on energy efficiency, sustainable practices, and then building materials that don't break the bank and in turn actually bring what could be just a standard Ontario code built home to a much higher performing type home.
Right. Yeah, because building code is the minimum. I think our codes are excellent, but they do represent the bare minimum that's required. So I think what Tom will be telling us about really is, what should we be doing above and beyond the code to make this house more sustainable, more energy efficient, and longer lasting.
Yeah, so here it is.
Well, there's an interesting concept, and we're still working with a building code that's from 2012. There's been a couple of variant modifications to it that have improved the energy efficiency aspect of it, but just a little bit. And we have a pretty good sense of where the building code is going to be in 2032. So that's only 7 years from now.
Right.
And my thought is we're building homes that are intended to last 80 to 100 years. Why on earth would you not build at least to the standards of the building code that we know is going to exist in 7 years versus something that is antiquated and um, not up to the standards that we should be building to? So you scratch your head, you think about that. Yep, that, and people they can get their heads around that and they say, yep, that makes sense. So there's a starting point where we can build better than code.
Yes.
And it doesn't mean we have to go to passive house standards. It doesn't mean we have to do a whole bunch of things, but to build a house airtight, to put more insulation than the current code requires, and let's go to the code of 2032, and to have exterior insulation, put in high quality mechanical systems that are going to provide energy efficient and low cost heating and cooling to the home. That to me is a no-brainer, because the cost to do things a little bit better than code is maybe 5 or 6 or 7% of the cost of the home.
That's great to know.
To build something to passive house, in my opinion, and you'll get very varying opinions on this, it's more like 20% more than the cost of a home. And that's a big nut for a lot of people to chew off if they're building a custom home.
Sure.
But to build it so that it's better than code, it's going to be far more comfortable. It's going to last a long time because you've selected a quality contractor who is installing all of these available products well. That's an easy decision.
Yeah, it's such a practical point. Why wouldn't we build to meet the needs of the next few decades?
Yeah, especially when the price point is just a fraction more than the original cost.
Yeah, and for that you get better comfort, lower energy bills, and far fewer issues with moisture and air leakage. Which brings us to another point that Tom made. How critical it is to build well,
Hmm.
not just to design well.
Yeah.
If you have a home that's designed with a really, to a very high standard, and it's got lots of insulation in the right places, it's got the right air barriers in the right places. If it is not built well, it's actually going to fall apart and deteriorate much quicker than an older home will. And the reason being that if you get air leakage into these windows when we've made the house or into these walls,
right,
there's this great, in our climate, it's very cold outside, it's very warm and humid air inside. That air wants to travel through the wall system. And if the air gets trapped in the wall system and there's moisture in it, then you're going to get moisture problems in walls. You're going to get wood members rotting. You're going to get mold. You're going to get all sorts of stuff. So a house that's really well designed but poorly built is actually a bigger problem than leave your home alone and don't touch it.
Right.
Because you are introducing opportunities for real problems, particularly in the wall assemblies. If people aren't using these tapes and the air tightness materials properly.
I've seen this myself as a realtor. Clients buy brand new homes expecting them to be perfect, and then discovering a few performance flaws just a few years later.
Sure. Now, if you're building a high performance house, the execution has to match the design. So there's an intent, but then that intent has to be carried through. Air tightness, insulation, moisture control, it all has to be done right.
Yeah, that's true. So let's talk specifics. Tom walked us through quite a few of these pillars, and we'll learn a little bit more about it.
All right, sounds good.
Traditionally, forced air heating systems were designed where there'd be a floor register and a heat duct below every window.
Yes.
And that was sort of falsely blowing warm air over the window so that you wouldn't feel the cold that's coming in through that window.
Yeah.
Well, if we're using a much higher quality window and we don't have any air leakage by that window, we've got very well insulated walls, all of a sudden we don't have to have a floor register by every window because there's not the heat loss or the cold gain that you used to experience. So now we can design a home with a smaller heating system, smaller ducts, if we're using forced air. We still heat rises. So if we didn't have a heating and cooling system in a house, whether it's summer or winter, the house is going to be warmer upstairs and it's going to be cooler downstairs because heat rises. And same with on a floor, there's going to be a slight temperature difference between at the floor level than at the ceiling level. And that's not because there's air leakage, it's just because heat rises. And we're adding heat to the house. We're cooking and we're showering and we're doing things. So we need to have some sort of an air handling unit for cooling. And therefore, by default, we need some ducts. So we need a ducting system for cooling. And that ducting system can be operated, even if it's just used for cooling, it can be operated with the fan on at all times. And that provides a little bit of airflow through every room in the house. And that gives us two benefits. Number one is the air is circulating so that we eliminate that problem with it's cooler down by the floor and it's warmer up at the ceiling. So there's uniform temperature throughout the room and throughout the house. And the other thing that we can do is we can introduce ventilation. So what we want to do, we've built this house that's super airtight. Well, if there's a bunch of people living in that house and it doesn't leak any air, where's fresh air coming from? You need fresh air. Otherwise, we're breathing out carbon dioxide. And that creates dirty, unhealthy air. So we need to ventilate that stuff out. And we do that even by code. We require something called an ERV or an HRV, which is basically a mechanical system, a pump that brings in fresh air and exhausts stale air. And it's intended to run 24/7 all the time. So you're always getting fresh air into the home. These things are efficient. The cold air in the winter that's being brought into the house is being heated by the warm air that's being exhausted, and they're very efficient. And it's a fantastic device. Obviously, there's different qualities. There's different energy efficiency models available. So we've got this air handler that's cooling the house, and even in the wintertime, you leave the fan on so that you've got ventilation. So you've got healthy air in the house, and you've got a little bit of airflow. Now we need to talk about heating. So we can either heat that air in the winter so that we have a forced air furnace or a heat pump, and we can talk to that in a moment, where warm air is being distributed through the house to heat it in the wintertime, cool air is being distributed through the house to cool it in the summertime, and it works great. That's sort of the bare bones standard systems that we install in a lot of homes. The other system for heating, if we don't want to use forced air, is hydronic heating, which is hot water heating, and very, very common form of heating in old homes from the 1800s on, with those great big cast iron radiators that you'd see in every room in a house. That's hydronic heating. That's pretty cool stuff. And we're using wall-mounted radiators if that's something that people want. And there are a number of manufacturers of very efficient, attractive wall registers which have hot water flowing through them. Something that's very common is radiant floor heating. So very, very common in Europe, and I'd say probably in 10% of the projects that we do, we'll have some radiant floor heating in them. But some people, particularly if they've lived in Europe or are from Europe, they have to have radiant floor heating in their home. They just say it's more comfortable. They're not wrong. It's not for everybody. It's more expensive than using just a simple furnace or heat pump to heat and cool the air, because we still have to have that air conditioning system with forced air, and yet we've got a full separate heating system that is based on hot water. So with a hot water heating system, we need a hot water source. And what is that hot water source? Traditionally, it's a gas-fired boiler. Well, a lot of people don't want to use gas. We don't want to burn hydrocarbons to heat our home. So the option there is to use electricity to heat our home, and people are using heat pumps. And heat pumps are just a refrigeration type cycle like we have with our air conditioning, but the cycle basically is reversed, and it's a thermodynamic cycle that basically sucks warmth out of the air outside and distributes it inside the home. Those systems are fantastic, but they get expensive compared to a gas-fired appliance if we want a boiler, for example. So we could have a heat pump hot water tank to heat our domestic hot water. We could have a heat pump boiler to heat water for heating the home. We could have a heat pump air handler to both heat and cool the home if we're going to use a forced air heating and cooling system. So it's complicated. A lot of thought has to go into it. The one thing that's for sure is you need a smaller system if you've got a better insulated and better airtight home than you do if you've got a home that leaks a lot of air and isn't very well insulated. If you picture a door, you close a door on the interior of your house and there's a gap at the bottom and there's a little gap all the way around it. That door lets air pass through those cracks. Similarly with an old home, and I'll go to a very old home, 100-year-old home. If it hasn't had any renovation work done to it, it's got old windows. It is probably made of brick, where the roof joins the walls, where the floor joists join the walls, where the walls join the foundation. Air flows through all of those materials. Air flows through brick, air flows through cracked mortar, air flows through the gaps around windows, air flows through the gap between glass in a window and the window frame. Air leaks through houses like crazy. And we determine the air tightness of a house by air changes per hour. And there's a certain test that can be done to determine that. If you were to take a 100-year-old home and do an air test on it, the way it sits today, it probably has 10 or 12 air changes per hour. And that means, when the wind blows, the candles flicker because wind is blowing through the walls and blowing through the windows, and it just leaks air like crazy. The house also has no insulation value. It's a very small insulation value that's afforded by plaster and brick. And so it has probably an R3 or an R4 insulation value. The biggest loss associated and the biggest thing that makes homes uncomfortable is actually the air leakage. So if we can seal up a house and stop the air leakage, we've probably made it 60 or 70% more efficient just by doing that. Wow. And then we make it that much more efficient by adding insulation value. So we've made the house airtight and we've provided lots of insulation so that the home is both airtight with lots of insulation value. By default, it's going to be more energy efficient. It's going to be less expensive to heat. There's going to have to be smaller heating appliances. It stays cooler in the summer. And therefore we don't have to spend as much money on air conditioning as we would in a home that leaks a ton of hot air in the summer.
Right.
Building a new home, it's pretty easy to get it quite airtight and quite well insulated. Even a code-built home can be quite airtight and quite well insulated, depending on who's building it.
Okay, yeah.
And depending on the products that are used. If you drive down through a subdivision or where a couple of homes are being built and you see them at the stage before any cladding's been put on, and you see this white paper on the outside, it's called Tyvek or Typar. There's a host of different brands. Yeah. It's a product that's stapled onto the outside of the house. You put some tape on the seams, but it's a far cry from making a house airtight, but that's all that's required by code. Wow. Because people don't go to the trouble of making sure every little crack and cranny has been sealed with caulking and tapes, etc. They just staple this stuff on the wall that's flapping in the corners. Nobody seems to care, and off they go. They stick on the bricks. A conscientious builder will use products that are better than that, and they will train the people and the people that are installing those products to install them properly. And that makes all the difference in the world. So two different builders, contractors can use the very same products and have a very different result in the quality of the airtightness of the home.
Yeah, I believe that. Are there any other components? I mean, like you said, there is this is a big topic, but let's say, what about windows and natural light in a home when it comes to selecting those products?
There are many different mindsets that people have, that architects have, that builders have, as it relates to the products that are being used in a home. So let me start with the statement that, and I'm just picking a number out of the air, 95% of the architects and designers out there who are designing homes or renovations pay very little or no heed to airtightness, insulation values, and they're looking at the Ontario Building Code, and they're using insulation values, et cetera, that just barely meet today's current building code. Right. As an aside, I think that our governments have been irresponsible. I don't think that our building codes have changed rapidly enough, and we're certainly not following the lead of several other provinces, many states in the U.S., and certainly most European countries. I hope we catch up, and I think that we will, but it's just taking a long, long time. So people are still designing to the bare bones minimum to meet the current Ontario Building Code. That being said, we can take a home that's been designed to barely meet the Ontario Building Code, and we can make some changes to it. During construction, we can add more insulation on the exterior, for example. We can use products that may not have been specified, better air barriers to make the house airtight. We can use more insulation value in the walls as well as on the exterior. And this stuff doesn't have to necessarily be shown on the drawings. One way that we achieve good insulation values is with the use of foams. So we use, or we can use polystyrene, expanded polystyrene or extruded polystyrene, that pink and blue stuff that you see at the Home Depot.
Yeah.
We can use spray foam in ceilings and attics and header spaces, basement walls, etc. However, there is a whole group of people who don't like the idea of spray foam or foam in general, because if you look at the carbon footprint of some of those products, they're pretty nasty. The manufacturing process is polluting. There's off-gassing when they're being applied, which is a bit hazardous and dangerous. And people are looking for more inert products that are better for the environment throughout their entire life cycle, through manufacturing to ultimate disposal.
Is that something like mineral wool or?
Yeah, there's a host of different insulation products. Probably, we can look at fiberglass pink. Pink is a batt insulation. It's been around for years. It's a quality product. We would take it up a notch and look at rock wool products, which are there's a local company called Rock Soul, which is now called Rock Wool, and they make different batt products and different exterior insulation products. Those products are not water resistant and they're not airtight. So when we're using back type insulation products or blown cellulose type insulation products, we have to have gain airtightness through building a better envelope. So using the right types of air barrier products, peel and stick products, the right tapes, the right gaskets, the right flashings to make sure that without any insulation in the home is airtight.
Right.
And that's a really important topic, windows. There's a number of things to look at there. First of all, it's been proven, and people like more light in their homes than we used to. We love to have great big sliding doors or great big windows in the back of our home, so they're really inviting the backyard into the house. And in our climate, obviously, they want to be closed in the winter, but very often they want to be wide open so that your living space extends into the backyard. So there's all sorts of fantastic products that allow us to basically have a curtain wall of glass at the back of the house. Some of it would be operating, i.e. a door or a bifolding door or a hinge door, but they can be multi-windows, and we've just got all of this glass. The downside to that is the best window in the world has an R value of about 12 or 14. And therefore, by default, if we're putting in glass and a poorly built but window that still meets code has an R value of 5. And that creates a problem because we've got a lot more heat loss through those windows. And the bigger problem is actually in the summertime where we have heat gain. If those windows are south facing or west facing, we can get a lot of sun coming in through those windows, which heats up the house, meaning that you've got to air condition it to get rid of that heat.
Right.
So it's a balance, and you can look at from a design standpoint. You can get shading. You can put overhangs to keep the summer sun out of the house. But the winter sun does come in because the sun is lower in the sky. And that all comes down to the design itself. The products. There's a lot of talk about double-glazed windows and triple-glazed windows, and it's complicated. There are lots of double-glazed windows that can meet the current building code. Where it becomes tricky is the amount of glazing or the percentage of the exterior of a home that is windows and doors as opposed to the other insulated cladding. And as soon as that amount becomes, as soon as you have 17% of the surface area of the walls of the house are windows and doors, then we have to use a window that's higher rated. And the way we rate windows as opposed to R value is we use something called U value, which is the inverse of R value.
Yeah.
So a lower U value is better for a window. And not that these numbers mean anything, but in the to the listener, but the metric unit is we need to have a window that has a U value of 1.6. As soon as we have 17% glazing, between 17 and 22%, we have to have a window that has a U value of 1.4. So it's better. And it's very hard to meet the U value of 1.4 with a double glazed window.
Okay.
Window manufacturers may argue with me, but that's my understanding. So our next step up would be to go to a triple glazed window. My preference is triple glazed windows in all applications regardless. And that's one of the things that we do. We almost never receive a set of drawings where they specified whether the windows are to be double glazed or triple glazed. It's tricky because people aren't taking that into consideration when they're designing the home to determine how much insulation is required, because they're assuming bare minimum to meet code.
Right.
So they're going to assume double glazed windows. They're going to assume that they're not particularly efficient. And that's unfortunate because we can do so much better if the design from the onset and the energy efficiency of the design is calculated using the actual products that are going to be used, so that there would be a specified U value of a window, there would be a specified R value of a wall assembly, etc. What I do talk to people about, and you alluded to this whole concept of designing for comfort, is on a triple glazed window, regardless of whether it's a passive house certified window with a U value of 0.8 or whether it's a quality but sort of standard built window, which might have a U value of 1.2. Because of the triple glazing and the double spaces with argon gas, et cetera, and the different films that are put on the glass, the inside temperature of the window, so inside the house, if you put your hand on the glass of a triple glazed window, the temperature of that, even if it's minus 15 or 20 outside, the temperature will be 17 or 18 degrees.
Wow.
If you had the very same window and even a very high performing double glazed window, the temperature would be 12 or 13 degrees. So you can imagine if you had a whole wall of glass and that wall was triple glazed at 17 or 18 degrees Celsius versus 12 or 13 degrees Celsius, you're going to be a lot more comfortable with one that has with a warmer wall.
Certainly. Yeah.
And what I talk to people about is I say, if you have a sofa or a chair 1 meter away from that big, huge wall of glass, you want to be able to sit there and be comfortable. And I would tell them that if that wall of glass is 13 degrees Celsius, you are not going to be comfortable. There's no air leakage, there's not a wind blowing past you, but there's just this cold wall behind you, which is a cold window. So I promote and virtually only sell and suggest to our clients that they use triple glazed windows. And in an ideal world, we would use a window that's significantly better than a standard window, and ideally one that's been passive house certified. And those U values get down to about 0.75, 0.8, 0.85, depending on the window and the door, which is very, very good. Super, super comfortable having windows of that quality in your home.
Sure. There's lots of topics on sustainability that we will be getting to in further detail in other episodes of this podcast. But let's talk in terms of air changes per hour. So the way I think of it is taking the entire volume of air in the home and how many times that entire volume of air gets replaced every hour. So you're bringing in fresh air from the outside and exhausting the air that was in the home already. So there's going to be some heat loss there or some air cooling loss in summer, because you are taking that conditioned air, that heated air, and exhausting it out and bringing in fresh air from the outside that now has to go through the heating and air conditioning cycle.
Yeah, yeah. Actually, as an aside, when I did my passive house intro course, I was shocked to learn about how much air goes through the house. You know, you're thinking you have your furnace that pumps out air, and of course, I didn't think, where does the air go?
Hmm.
It's going through the little cracks.
Yes, there is that, but there is, in a newer home, it's not intended to do
It's
that,
not
right? Of
supposed
course,
to.
it's
Yeah,
supposed to go
yeah.
out through
The
the
means it's
the
supposed to go
the
through. Yeah,
the
yeah,
means that have been put in place
exactly.
to allow that
Control.
air in and out in a controlled manner.
Yeah,
That's right.
yeah. But in old leaky homes, they go through all sorts of little
Sure.
nooks and crannies. I
Yeah.
had no idea.
Yeah.
Anyhow, summing up this portion on building strategies and building materials that help make homes more sustainable, last longer, perform better. I feel like the takeaway here is that if you are looking to build a brand new custom home that is comfort driven, getting a sustainable home builder like Tom, who is really focusing on that comfort driven home at the same time as involving an architect, really will help the situation,
Yeah.
right? Both
Yeah.
when it comes to the financial means of the project, the goals, and the materials that we're using. So, before we wrap up today's episode, Tom and I touched briefly on renovations because that is a whole part of his business as well.
Hmm.
And that's like a whole other can of worms.
Sure.
So, here's a quick little peek on what he had to say about that.
Renovations, one of the biggest, we're talking about new homes and building new homes. Well, there's hundreds of thousands of old homes, which are completely and totally inefficient, and that stock of housing has to be improved. There are other cities like New York, for example, where they've mandated that all buildings have to be brought up to a certain standard, and whether those are residential buildings or commercial buildings. You don't normally think of Manhattan as being that forward thinking, but absolutely there's a major renovation effort going throughout the entire city, to upgrade all of the existing buildings and to bring them up to a standard which is frankly much higher than the standards of our current building codes. The other problem, of course, is the building codes as they relate to renovations are really lame. There aren't any.
Oh.
The only thing you can't make it worse than it already is. But you're allowed to make it better.
Right.
And that's the only mandate as it relates to energy efficiency when renovating a home.
Wow, I had no idea.
And that doesn't make any sense to me.
No, no, it certainly doesn't. I mean, in BC, I know that they're really trying to kind of do an implemented approach to renovating and retrofitting homes so that they're net zero or what have you. So yeah, I would love to see that come here in Ontario. I mean, we spend so much money in Toronto, especially. Real estate is so expensive. Why buy a $2 million house that's going to crumble and just fade away? You want a $2 million house that you can maybe put some money into, and then that the next buyer will see value in as well.
Well, that's exactly it.
So yeah, I think what Tom is trying to say here is that by making renovations, you're doing better, but unless it's intentionally meant to be sustainable, then you're not kind of hitting that next level in performance when it comes to renovating homes. So before we go, I love what Tom said about building houses or renovating houses even for people who plan to stay. Those aren't short flips.
And that's who this show is for: homeowners, renovators, builders, agents, anyone thinking beyond today.
Mhm. Yeah. I think if we want a better housing stock, we need to build and renovate with intention.
Hmm.
A big thank you to Tom Cumming of Severn Woods for all his insights today. We'll be speaking with him again soon and dive into the world of renovations because, like I said before, that's a whole other can of worms. And yeah, so hopefully you'll join us for that one.
And if you like this episode, be sure to like and subscribe and tell your friends.
It really helps. Thank you so much.
Thank you.
Until next time.